this is the question, length of the longest valid substring. And here, this is marked hard. This is actually not that hard. So basically, we are given an array of forbidden words which we cannot use. So the substring should not have any forbidden words. And basically, we have to return the longest substring. So basically, uh, here, the substring can possibly also be of length 0. And here, the simple thing is we just have to return the length. We don't have to worry about the substring itself. So now, if we are given this CBAAAABC, right? So let us try to think of this logically. Um, that how will we approach this, right? So one thing can be that we can grow the substring one at a time, right? Like we can consider substring of length 1 2 3, like 0 to 1, 0 to 0, 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 5, and so on and so forth. Now in this we also have to find, then after doing that, what should we do? So basically here, uh, so we have this, right? So of length, the first length can be C, right? The second length, so on and so forth, can be CB. The third length can be CBA, right? The fourth length can be uh, CBAA. Then it can be CBAA. Then it can be CBAA AA, right? Now what next? So the idea can be that as soon as we get this, right, we start checking that uh, basically, is any forbidden word possible? Now there is a trick here, right? The trick can be that instead of checking from the beginning, right? Like here, instead of, like, let's say this, instead of checking here, like starting at the first index, index 0, how about we start from here, from the other end, right? And check whether a word actually ends uh, at the basically word of some length ends at the last index, right? So why is that useful? So let us say that here, C, can we check word of length 1, right? What is the word of length 1 at line 6? It is C. What is the word of length 1 at line 7? It's B. What is the word of length at line 8? Of length 1, it's A, right? Similarly, is C valid? Yes. So the max length here will be 1. Here max length 1 is possible. Yes. That is just B. How about max length 2? Is that possible? CB? No, that's not possible. So we will again, we will not update max length. Now here is max length 1 possible. That's 1. Is max length 2 possible? That's BA. Yeah, that's possible. Now is max length um, 3 possible? So the point here is that we already know that the left, we so basically we already know that um, that CB is not possible. So here we can update left to be 1, right? Here, so yeah, I mean, I will walk through that in the code as well. So whenever we find a word that ends at a given index, right, then uh, we can update um the left value accordingly, so that whenever we are counting the length, then we for sure know that a given forbidden word does not is not contained at that position. So basically, now one interesting thing here is that what should we, once we update this, right? Once we know that CB is here, then what should we know that CB is forbidden. So what should we update the L value to be? We can update the L value to basically start of the word. Um so yeah, in this, actually this is we let's take, this is just a two-letter word. CB is just a two-letter word. Let us say that so basically we can always In CB, we can always we can just place the index at one plus the start, right? So let's say in CBA, the left here will already be one, and the right value will be two. So we will just have basically right minus left plus one, right? And uh, right is two. So right minus left plus 1 will become 2, and this is actually this value. Now in BAA, in CBAA, let's try to figure this out. The left value is already 1. Now after that we have BAA, so which is not forbidden. So max length here will be 3, right? Now when we have this guy, right? So this, yeah, so basically this is a good example. So here we have this. So we will first check A, right? Then we'll check AA, and then we'll check AAA. Now AAA triple A is actually forbidden. So what we will do here, basically we will put forbidden. We can start counting the correct word right after this guy. So basically we know for sure that AA is not included. So we can start counting from the second day itself, right? So this is 0, 1, 2, 3. So left now will be 3. Why? Because we cannot include the first character because that is forbidden, but we can start including the second character. And now left will be 3 for sure. And the right here we know is 4, right? So basically left minus right, and then so now max length won't change, and then we have CABB. So now this is B, right? Let's try to fill this. So we have so let's say this. So right is now 5, right? And then we will check A, we'll check B, which is fine. We'll check AB, which is also fine. We'll check AAB. That should also be fine. We'll check AAB. Now the point is that we now the point is that we don't need to go beyond L, the left value. So here, right? So even when we are at 5, we can just check 5 and 5 4 because we already know and basically 3 4 5 because we don't need to go to 2 because that was already checked previously. So here, the max length again will be 3. There will be no change. And yeah, so now we are good. So now let's check this example. So in this is the last example. So here we'll check C. So the R values here is 6. Let's check C, right? Then BC, then ABC, right? And then ABC. So now AABC is the perfect example for us. So now the max length is 4 and AABC is also good. And then basically we will not go for AAABC because length is uh, left is 3. So we'll check till this guy. So let's try to code this, right? So we can say max length is 0, left is let's say 0, and then for right in range, so let's say n is the length of the word, right? So for r in range n, right? So we'll go from check from length 0, 1, 2, so on and so forth. Now, for checking, now once we get a right index, we will check the left index afterwards, right? So, so here, like I checked this. So this is actually a pretty important thing that the forbidden word cannot have like infinite length. So here the forbidden word can only have the length equal to 10. So this is pretty useful for us because the actual length of the word is 10 power 5, right? So 1e5. So here if the actual length of the forbidden word, right, is just 10, so each forbidden word can at max be 10. So that is pretty useful for us. So what we can do is that, let's say we take index in range. So now we need to start picking up a word. So let's say index can be r, right? And then basically, so let's say we are at index 0, right? So So basically now this is a little bit tricky. So what we can just do is we can say that so one is, let's say, r minus 10, right? And then that is one thing. The other thing is that, let's say if you are at index 0, then r minus 10 will become minus 10, right? So we need to stop this at, let's say, minus 1. Okay. Now that is the thing. Now let's take the current word. So here we can do slicing of the word. This can be word, uh, so basically, what we can do is that the word starts at index, right? So let's say we want this word to, um, begin at the word index, and then it has to end at r plus 1. Why r plus 1? Because let's say of at index 0, index will value will be 0, and r value will also be 0, right? So, but we need to take the first character. So for taking the first character, this should be 0 to 1, right? So basically, if cur word in forbidden, right? So yeah, this is also one thing that let's convert forbidden to a set. So if cur word is in forbidden, then what we can simply do is uh, L can be, let's say, so basically we cannot include index because index is forbidden, but we can just place it at index plus 1, right? Now basically, uh, simply what we can do is that after we, so basically the thing is, because we are growing from the rightmost index, right? So L is actually going from, let's say, its index value is first starting from here, then going here, then going here. So the first value that we find, because we are going from right to left, is actually going to be the max value that we can forbid. So as soon as we hit this, we can break this, right? And basically, once we break this, what we can just do is that max len can be max of max len and r minus l plus 1, right? And then we can just return max len. Uh, so yeah, so as you can see, there are there is still one test case which is failing, but and this is actually a good test case. Uh, so I actually made this mistake on purpose. So because actually, yeah, this is a tricky problem. So, but I'll show you these two test cases will pass, right? The normal test cases will pass. So you can see this is 544, and the expected value is 444, right? So these two test cases are passing. So what is the mistake here, right? The mistake here is simply that here, if you see, right, uh, this is actually what makes this, I believe this is what makes this problem hard rather than medium, is that, so let us say if you take this example, right? Um, uh, let's say this. So, right. So now, so at what, so basically, the just the simple thing here is that left can actually be a, if left was later, right, was at, let us say that if I just, so if I just work with this example, right, so let's say this, if r minus l plus 1 is greater than max len, right, let me just put a print here. I can say print l comma r, right? So, so as you can see here, right, this is the case which breaks, which is 5 and 9. So what is the problem here? So let's say this is 0, 1, 2, 3, 4, 5, right? So this is 5 and then this is 6, 7, 8, 9. So yeah, so basically, uh, uh, and let's also print this. Let's print this L comma index plus 1, right? So as you can see over here, what is happening is L was 0, index plus 1 was 1, L was 1, index plus 1 was 2. But here L was 6, but index plus 1 was 5. So this is actually what is causing the issue. That basically when this scenario comes, that L is actually 6, but then it finds that, you know, that BAACC, right? If this is the case, then basically this will try to test all these values. So basically, if we just try to do this, right? So basically, we just need to check till L. If we check beyond L, then it starts to cause a problem. So yeah, let's try to run this now. So now you can see that it passes fine. So yeah, that is how we can solve this problem. And basically, what about the time and space complexities? So let's just say this. So time complexity is, so let's say we want to go to n, because every time, like every character, and then this is at line 26, and then basically after that we have to go this 10 times, right? And then basically we just have to slice at 26. So this is also at max 10, right? Um, so yeah, basically this is O of 10 plus 10, and then yeah, and basically this is just checking in a set. So this should be of 1, we should be fine. And then as soon as we hit this, we break. So yeah, this should also be fine. And then for space complexity, we are actually just um, what are we doing, right? So we are actually just storing numerical values, integer values. So yeah, this should be O of 1. Yeah. So let's try to run this once more. Yeah, as you can see, I ran this actually a couple of times. Okay, yeah. Thanks. Bye.